Dr. Sirisha, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to look at the concept of stacks and its applications. Yeah. So let's have a look at what a stack is. Stack is nothing but a linear data structure which allows its data to be inserted and deleted from the top end only. At one end, the other end is sealed and we do not have any access right towards it. Right? So the structure of any stack can be viewed like this, right? So you can see that on top it is open. That means if you want to insert, that is push an element, you can push from this side. And if you want to delete an element, that is pop an element, remove the element from the same side. The other end of it is sealed. You cannot access it. Right? This is the beauty of stacks. It is not at all a negative point or it is a disadvantage. Never ever think of that. It is not the disadvantage of a stack. It is the beauty of the stack. A special purpose is there for a stack to stop the push or pop operations from the other side. The structure itself is like that. Right? So then coming to the applications of stack, where we can use these stacks. First and foremost application, I'm going to discuss about only 3 applications in my case, which is very, very important. Expression evaluation. First one is expression evaluation, where humans understand only infix expressions. What do you mean by that? For example, we understand only A plus B, where A and B are variables. Or even I can say that 2 plus 5. Immediately you are going to say 7. What if I write it in this form? Plus 2, 5. What is the answer of this one? You might be thinking that it is 25 but not 2 and 5. Right? What if I write this in this fashion? 2, 5 plus. Can you evaluate it? No. So that is the basic difference. Humans understand infix expression, whereas system understand postfix and prefix expressions. Right? Especially postfix expression for evaluation of an expression. Of a given infix expression, to be more precise. Right? So whatever the infix expression is given, it is converted into postfix and then evaluated, and the result is then displayed. That is the first and foremost application of a stack. And how an infix expression is converted into postfix as well as prefix expression is covered in my videos, one of my videos. Please go through my ideas. Here we are to discuss some other applications, a very new application which we'll see now. Okay, then coming to the second application of a stack, which is parenthesis balancing. Parenthesis balancing. Then what do you mean by that? For example, while writing a C code, okay, or you can say C++ code or Java code, we use flower brackets to show that it and the set of statements inside it is a compound statement, right? They are a set of statements. Say I have declared something like this. These lines represent few pieces of code programming in some programming language. Then how stacks are used for in parenthesis balancing. If we take a stack, okay, initially my top, the variable which points to the topmost element of the stack, is pointed to -1, the default value, because the stack is empty right now, right? So let's start working with this one. The syntax to check any compiler while going for syntax errors, it uses stacks. The first is open parenthesis. It is going to insert only 2 funda, as it is parenthesis balancing. I have only 2 things in my hands. Either it can be an open bracket or it can be a closing bracket, only two, right? So as I have inserted an element, the top will be pointing to the top element, that is the top opening bracket. Now, due course, I have encountered another opening bracket. I'll insert that into the stack. Once I insert that into the stack, my top gets incremented. Right? After execution of few lines, I encountered a closing bracket. Whenever I encounter a closing bracket, I'm going to pop a bracket from the stack. That is, I'm going to pop an element from the top. So now again, my top got decremented. So in due course, I encountered one more closing bracket, and I'm going to pop the opening bracket saying that your matching closing bracket is appeared. So as I have removed the last element in the stack, top will get the default value, which is -1. It means I have started with an empty stack and I have reached the empty stack. Started with an empty stack and ended with an empty stack, which tells that the given set of statements are balanced, parenthesis balanced, right? But this is the second and most important usage of stacks, which are used for parenthesis balance, right, guys? Next, let's look at the third application of stacks, which is function calls. In case of function calls, let me take an example. Say there is a function which is going to call function 1 after few lines. Okay, here function 1 is defined, which is going to call function 2, and here I'm going to define my function 2, which after few lines got ended. Now my point is, when the compiler starts compiling the code, it starts with fun, it executes these statements, and it encounters fun1, that is a function call. So once this function call raises, it is supposed to go to the function definition, which is fun1. But once the execution of fun1 is done, where it is supposed to go? Does it have any written address? It doesn't have any address. For that purpose, stacks are used. Say, for example, your function is located at location 2000, and at say 3000 location, function 1, function call is present. Whenever the compiler encounters the function call, it stores the address where it is been called. So 3000 is the location, and my top is going to point at the same, right? So with this, function 1 gets invoked and its execution starts. In due course, function 2 is being called. Say, if it is at location 4000, its address is stored in a stack. Now my top is going to point to location 4000, right? So with the function call, function 2 gets invoked and its execution starts. As it is not calling any function in return, it ends. As soon as function 2 ends, now it comes to the mind of the compiler who called it, right? So it will reach the stack to get the address where it is supposed to return back, which is pointed by our top, which says 4000. So the control will resume at location 4000 and start executing. Meanwhile, our stack, as it has used the top location, it is going to decrement the top value, or you can say that it popped the value on the top, right? So once function 2 finishes its execution, once the execution of function 1 ends, it will think of where it is supposed to go, who called me, right? It will approach the stack. Stack will say that go to the location 3000, right? So go to the location 3000. It goes to the location 3000, resumes its functioning or function. So it ends. So thereby with this closing bracket, even the function ends, right? This is how a stack is used. A stack is used to store the written addresses. Guys, remember, stacks are used to store the written addresses of function calls. The same written addresses can be used in recursions also, as recursion is also a kind of function. Let's remember this point because I have not seen any videos where they have explained with example and written addresses how to store all these things. Okay, so these are the three basic applications of stacks which we are keen about while we are studying our BTech graduation kind of, right? Now let's go deep into one of the applications of stack. That is the first application, which is evaluation. Within evaluation of expression, we can see that there are three kinds of expressions, as I have shown you: infix, prefix, and postfix. As I have already mentioned, I have posted a video which gives you a basic demonstration of how to convert an infix expression to prefix and an infix expression to postfix. In this video, we are going to look at how to convert in the reverse order a prefix expression to infix and prefix to postfix. Before going to go there, let me explain you how to convert an infix expression to prefix as well as postfix. Okay. Let me take an example. A plus a random example I have taken. That is an infix expression, which is A multiplied by B plus C. Let me convert that into a prefix expression. Always start from left to right. Okay, and precedences of operators is the most important point that you need to remember over here. The highest importance will be given to brackets. Please keep that in mind, guys. Brackets. So B plus C is the binary operation which is present within the brackets, which will get the highest precedence. So first of all, convert that into prefix A star. This is an intermediate result where the first operand is A and the second operand is plus BC. Right? Now a prefix of the same. Place the operator first, that is star, followed by operand 1, which is A, followed by operand 2, which is plus BC. Right? So this is the conversion of a given infix expression to prefix. Then how to convert the same expression to postfix. Order is same, precedence is same, but the way you place the operands and operators change. Have a look at this one. Okay, so the first one that is going to get the priority is the binary operation which is present within the brackets, that is B plus. The postfix expression of the same is BC plus A star. That is the remaining one, right? So have a look at this one. The first operand is A and the second operand is BC plus. Now let's convert that into postfix. First operand, second operand, followed by operator. Have a look at this one. This is the conversion of an infix expression into a postfix expression. This is how we are going to always travel from left to right. Considering the precedences of the operators, we are going to convert. Intermediate results you are going to get, right? The same thing we are going to do in case of converting an infix given prefix expression to infix. That is the reverse one that we are going to do now. Previously we were looking at infix to prefix and infix to postfix. Now let's have a look at the reverse one. Now our point of concentration is postfix to infix, reverse. Have a look at the algorithm. Consider or read the given postfix expression in the given order, in order. That is from left to right? The basic one. Why I have insisted or I have marked in red is in case of prefix expression to infix, we have to go in the reverse order, that is from the right to left. So you will get a note on this in my previous video. Please go and check it, where I have given a demonstration on conversion of prefix expression to infix expression. Okay, guys, come back. Next, there are only two cases. As you have seen, you can have either an operand or an operator. What to do if you encounter an operand? Push it into the stack. What to do if you encounter an operator? Pop top two elements from the stack, concatenate them. How to concatenate them? Have a keen look into the red equation, the equation which is highlighted in red color, my dears. I have clearly mentioned top of the stack will be operand 2 and the next element to it will be operand 1. Right? So this is how we are going to do it. Operand 2, operator, operand 1. Enclose them within brackets. Okay. Perform the same unless you reach the end of the postfix expression. Once you reach the end of the postfix expression, job is done. Okay. Now, let's have a small demonstration of the same with an example. I have taken a postfix expression. I have to start from left to right. The first character is A, which is an operand. Push it into the stack. Next one is B, even that is an operand. Push it into the stack. Next is C, push it into the stack. Now you encounter the fourth character is an operator. What did I tell you? Take the first top element as operand 2 and the next as operand 1. Concatenate them with the operator. Right? As minus is the operator, I have concatenated. Right? The next one. Addition. For addition also, as it is an operator, I am going to do this here. The top is pointed with the sub-expression B minus C. Place it as the second operand. Next one as the first operand. Concatenate them with the operator which you found. What is the operator which you found? Plus. Concatenate them. Let's have a look at this one. I have used brackets. Always use a pair of brackets while you are converting a postfix expression to infix to show the intermediate results, how you have converted correctly. Okay. Next character that is encountered is D, which is an operand. Push it into the stack. Next is E, even that is an operand. Push it into the stack. Next comes operator, which is minus. Have a look at this one. The top element becomes second operand. Next becomes the first operand. Concatenate them using the operator. So D minus E is the result. Right? Now, what is the next character that is encountered? Which is F. It is an operand. So I have pushed it into the stack. Guys, I am going to carry forward the last or the current status of the stack to your next slide. That's the beginning. Okay. Now, what is the next character? G, which is an operand. Simply push into the stack. Next is an operator. Guys, think. Now, you answer. G will be the second operand. F will be the first operand. Concatenate them using the operator minus. Right? F minus G is pushed into the stack. Next character that is encountered is H. Simply push it into the stack. I pushed it into the stack. Next is addition. Addition means we have to pop top elements and perform. Guys, just for a rough sketch, let me do that. So H will be the second, F minus G will be the first. I'm going to concatenate them using brackets and then the operator in between. Let me check whether I'm going to get the same or not. Yes, I got the same. Right? So F minus G plus H. Right? Next character is division. Right? Again an operator. Perform the same. Here the top element will be acting as second operand and an element below it will be acting as first operand. Have a look at this one. So D minus E by F minus G plus H. This you need to remember this one because for addition you add 1 plus 2 or 2 plus 1 it will be the same. But when you perform division operation 2 by 1 is not equal to 1 by 2. What do you think, guys? 1 by 2, is it equal to 2 by 1? It is not equal, right? So be careful while learning this one, which one is operand 1 and which one is operand 2. I'm insisting this one, why? Because the top element acts as operand 2 but not 1. Okay, right. The next character that is encountered, or the last character I can say, is multiplication. Okay, so this is the final result. Have a look at this one. You can see that all the intermediate results are encapsulated between a pair of brackets. For example, the intermediate result you can say B minus C, or you can say D minus C. All these are intermediate binary operations which I'm going to perform, like F minus G, or even you can take this as an intermediate result where F is one of the operands, H is one of the operands, and F minus G is the next operand. This is how we are going to convert a postfix expression to an infix expression, right? So let's go to the second method. How to convert a given postfix expression into a prefix expression. Yes, there are two ways. First way is, you can call it as a lengthy way also. Convert this postfix expression to infix and then convert the given infix expression to prefix. This is one way. The first step, postfix to infix. Second step is infix to prefix. The second way is directly converting the postfix expression to prefix expression. Totally, there are three steps which you can see, right? So all these three methods will use stacks as an intermediate agent. They use stacks for their work, right? So such is the importance, such a huge importance stacks have in case of your arithmetic logic unit, when you work with an arithmetic logic unit. Let's have a look at the algorithm, how to convert a postfix expression to prefix expression directly. So read the postfix expression in the given order, that is from left to right. Even here we have only two cases. Either you are going to have an operand in your hands or an operator in your hands. What if you have an operand? Push it into the stack. Simply push it into the stack. What if you have an operator? Pop two operands from the stack, concatenate them into a prefix expression and place the result into the stack. Have a look at this one. I have not used brackets, my dears. I have simply I have concatenated in this order: operator, operand 2 and operand 1. Right? I have concatenated them and pushed into the stack. You have to repeatedly do this one from step 2 to 5. Repeatedly do this until unless you reach the end of the given expression. Let me explain you this with the same example. I have converted this example from postfix to infix. Now I'm going to convert this into the given postfix into prefix. Okay. I'm going to start from left to right. No issues in that. Right. So first is an operand. Place it into this tag. Second one is also an operand. Place it into this tag. Third one is also an operand. Place it into this tag. Coming to the fourth one, which is minus operator for two elements. Guys, I hope you remember what did I tell you? The string will be operator plus operand 2 plus operand 1. Always remember, guys, top element will be operand 1, element below it will be operand 2. Have a look at this one. Here, operator which they have given is minus, operand 2 is B, operand 1 is C. So the answer is minus BC. Then an intermediate prefix expression is minus BC, which is pushed into the stack. Please, guys, keep these points in mind, which are very helpful in not only learning the concept as well as placement's point of view. Okay, then what is the next character that is encountered, which is addition? Place the operator first, which is plus, then the second operand, which is A. Here, let me write, this is operand 2 and top is pointed by operand 1. So operand 1 is minus BC, operand 2 is A. So the concatenation gives plus A minus BC, right? Next character is D, which is an operand. Just push it into this tag. Next character is E, which is again an operand. Push it into this tag. Now guys, you guys try to do this one. The next character which we encountered is minus. How to do this one? What will be the next one? Operand 1, operand 2. So the operator, first of all, operator which is minus, followed by operand 2, then operand 1, minus D. I think this is the answer. Let me check. Yes, this is the answer, minus D. Okay, got it? So this is how we are going to convert. Okay, let's proceed. The next character is F. As it is an operand, push it into this tag. Next, I'm going to carry forward this last or the current status of this tag to the next slide. Where did we halt? We started from the left and now we are at character F, which we pushed it to the stack. Here. Now the next character to be considered is G. As it is an operand, simply push it into the stack. I pushed it. The next character is minus. As it is minus, the first top is pointed by operand 1. Second is operand 2. So what is the operation? Minus operand, first of all, first operand 2, then operand 1, minus FG you are supposed to get. Yes, we got minus FG, right? So on the top of the stack you have minus FG, after that minus DE, right? So the next character that you are going to encounter is H, which is an operand. So push it into the stack. Simply push it. Next character that you are going to encounter is plus. Let's think wisely. Top is operand 1. Below it is operand 2. How to concatenate? Please remember operator, operand 2, operand 1. This is the concatenation that we have to do, right? So plus minus FG, H is the result. Okay, the next character that we have to read is division. on top of the stack is plus minus f g h. This is operand 1. Operand 2 is minus d operand 2. Okay? Then concatenate them. This is the result. Slash minus d, because slash is the operator which we are going to consider. Now, then this next one is plus minus fgh is the operand 1, right? Let's go with the last kind, which is multiplication. So when we perform this one, the top one is operand 1 as usual, and below it is operand 2. And I have concatenated with the operator multiplication. Thereby you can see this is the final result. Guys, if you want to go for a reverse order checking, you can do that. In my previous video, I have given you two processes. One is prefix to infix and prefix to postfix. You can go through that video and you can cross check. That is, you can do reverse engineering to check whether the prefix expression which we got just now is equivalent to the question or not, the given postfix expression or not. Or even you can check whether this prefix expression can be converted into infix expression which we got in a previous sample, right? So this is how you can convert a given postfix expression to infix as well as prefix expressions using stacks. That is the beauty of the stacks, with which you can convert into all these modifications. Guys, you need to understand, never ever compare a stack with a queue, right? Why? Because as you have seen, stacks have a restriction saying that you cannot insert or delete any element from its other end. It relies on a funda known as last in first out, right? It relies on the funda last in first out. The element which is last inserted will be the first element to be removed first, right? This is the funda of a stack. Coming to the funda of a queue, it is first in first out, which says that the element which you are going to insert first is going to be the element which you are going to remove first. To perform this operation FIFO, it needs a structure in such a way that it must give access rights, right? It cannot bar an end saying that no operation should be performed. Queues must give access rights to both the ends, making two ends naming with front and rear, saying that, and queues are going to restrict in their operation, saying that you can insert an element at the rear end and you can delete an element at the front end. So if I insert an element at the rear end and keep on moving, then the element which is being inserted and the oldest inserted one, the element which was inserted in its early stages will be the element which will be removed first, which will be at front end. So these are the two applications based upon the requirements or the working of our system. People who have designed it have come up with these data structures where stack goes with the last in first out and queues goes with first in last out. There is no point in comparison with them. Based upon the requirement, these structures will be used. For example, say for parenthesis balancing or for function calls, we cannot use queues because even, yes, there is a point you can also debate, guys, saying that every stack can be converted into a queue, whereas every queue can be converted into a stack. But the primary point is most of the memory space will be wasted or you will be needing two stacks to make them behave like a queue, or two queues to make them behave like a stack. That is the problem. Everything is replaceable, my dears. There is no point in debating on that. But the primary concern over here is these two are two different kinds of structures which are used for the implementation or for the working of a system where the ease of working is the ease of working carries on. Okay. For example, a simple example I give my dears, there is a source which is sending packets to its destination network. Okay, it is an asynchronous way of transmission. What do you mean by asynchronous way of transmission? That is the rate of speed at which the source sends. Destination is not capable enough to hold that data, right? So what happens in that case? The source keep on sending the data which the destination network cannot handle. So what it does is it maintains a queue. So whatever packets come, rather than losing them, it places them in the queue. For example, say 1, 2, 3, 4, 5. It is keep on sending. Destination is working with packet 1. So it's going to place the remaining in the queue. Say 2, 3, 4, 5. So 5 acts as the rear end, 2 acts as the front end. So delete the element at the front end. So 2 is being used. Now if source sends element 6, it will be pushed at the rear end, which is 6. Now our rate is going to point to 6, whereas front will be pointing to 3, right? Front will be pointing to 3, right? This is how the data can be maintained. Can you imagine a stack in this place? So where it is restricted to work at one side, right? So we cannot imagine a stack being replaced with a queue in this scenario where there is an asynchronous transmission going on, right? So I hope you understood this topic. Please do refer my videos on different conversions, that is infix to prefix, infix to postfix conversion, and evaluation, that is the primary application. As I said, evaluation of an infix expression. Say you are given an expression like 2 plus 3 by 5 into 7 plus 5 by 2, something like this. How to evaluate this infix expression? It will be converted into postfix and the postfix expression will be evaluated. How to evaluate that using stacks is been covered in those videos, and in my just recent previous video I have covered prefix to infix and prefix to postfix conversion. Do follow that and try to understand all these conversions. All these conversions are very, very important in point of your competitive exams in near future as well as placements. I hope you understood this video and were following the same. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.